Welcome to the first part of the DISEMM tutorial. In this part of the tutorial I want to explain the first steps of the evaluation and the features of the main window. After the first startup, DISEMM should look like shown on the screen. Here on this side there is a progression meter which indicates if the data for the evaluation step is loaded in. If so, the dots will turn green and DISEMM will grant access. So now the first task is to define the sample and its composition. So for now we will focus on this section of the window. At the beginning we will have to load the crystallographic data. The used file format is CIF. This format is commonly used in crystallography to define the given crystal structure in appropriate file format. An example is also provided in the manual of DISEMM. And the link at the bottom of the screen will also lead to additional information about the CIF file format. And now let's open the CIF file. As an example I will use common stainless steel. And now as DISEMM finished loading the information from the CIF file, the dots turned green and the information is displayed here. So now there are only two things left to do. We first can decide a name for the evaluation, and below that we can define the sample area. This area is defined by the sample and the applied force during the experiment. So for example, during an uniaxial tensile test, the force is applied along this direction. Therefore the area is defined as a cut through this cylinder here. So now after we completed those tasks, we are ready to define the phases of the sample. In case of multi-phase materials, this combo box lets you switch between the phases. Down here we select the phase type. In this case it is switched to inclusion. So now we open up the drop-down menu. Okay, then inclusion type is equal rank. And since it is only one phase, the phase fraction is correct at 1. Before we add the 1D diffraction pattern or the peak files, we must enter the correct wavelength, which in our case happens to be just right. The second value constrains the pattern to certain limits. DISEMM won't detect any peaks beyond those borders. While adding diffraction pattern, DISEMM executes a routine in which it determines the peaks according to the crystal structure and automatically fits them. The settings for the routine, as well as different plot settings, which I later explains, are found here. For a detailed overview over the options, please refer to the manual. Now we can finally add the diffraction pattern or peaks. To add the peaks directly, please use the indicated buttons and select the file. DISEMM reads text files and needs a specific format. As shown on the screen, the file should contain columns for the experiment information as well. But be aware, the peak identification in the first column is done very specifically. For more information, please check out the manual. In this tutorial we will instead use 1D diffraction pattern. DISEMM supports multiple ways to load in the data. One can load files or folders via selection, or more convenient, DISEMM allows to drag and drop the files directly onto the pattern list. As mentioned before, DISEMM will automatically find and fit the peaks. The progress is shown at the bottom of the screen. Now that the data is loaded in, we can select the pattern in the list. This will fill out the information on the left and on the right. On the left there is experimental information, the sample positioning, the applied stress, and so on. For more details on how the experiment is performed, please refer to the publication at the bottom of the screen. Now for the purpose of this tutorial I will load in additional experimental data. Normally the experimental information is not attached to the diffraction pattern. This makes it necessary to add the data manually or half automated. DISEMM supports a fast edit right after the selection in the list, but also implements a fast fill window with additional features. Now in the center there is a data table which editing functions are pretty similar to Excel, which allows for a fast modification. Additionally, there exists an automated fill from file name or text file below. For more information on this feature, please check out the manual. Now we come to the right, which displays a combined peak list of the selected diffraction pattern. When hitting on the arrows, a second list containing the peaks will appear. The list contains information on the detected angle, phase, and HKL. The pattern list in the center also supports multiple selections, which also influences the peak list. It will now display all the patterns as before, just combined. Now we arrived at the last part of this tutorial, the pattern plotting function. This function is only available if 1D patterns are added to the evaluation. The plot is combined with the diffraction pattern lists and will be updated whenever the enter key is hit. So now let's take a look on how it looks like. Down below we have the 2θ angle, on Y the intensity. In the same way as before with the peak list, DISEMM supports multiplot. This means selecting the desired patterns and hitting the enter key will plot every selected pattern in different colors. Now we come to the toolbar on the top, which contains different settings for the plot. The first values for the X and Y axes are used to scale the plot to after hitting set. And the button changes the axis to logarithmic, and the button right next to it rescales the plot to the data. And now we have arrived at the end of this video, and I want to thank you all for watching.